We have briefly talked about functions before, but now we'll go over them in more details before we bring our data to R. Because we don't have our own data yet, it's a good time for me to show some data sets that already come in R. When I googled R datasets, this was the first result I got, and it just lists all the datasets that come automatically loaded in R. If you find a dataset that seems interesting, you just do the function data and the name of the dataset. So now you have this data frame loaded into your environment. We've also talked before about how to see data. This dataset's not that big. If I just call the whole dataset to the console, I could look into it. It's only 71 rows. Would not be a good way to explore my dataset if it was longer. So before we presented some functions such as head, you see just the first 6 rows. Dimensions to see how big the dataset is. And the best one is structure, which gives you each column, so each field in the data frame, and what class it is. So weight is numerical, and then there is a factor with 6 different feed types. We're also going to load the dataset trees, which has 3 numerical columns with 31 observations. The first thing about functions is how do I find the one I want? And I've shown that if you have a function you want to use, it's always good to type question mark and the name of the function. In this case, I tried average, it didn't exist. So I put 2 question marks, and it will look on several functions descriptions to see if the word average shows up. So it's not looking for a function named average, it's looking for functions which description have average on them. I've already shown what happens when you do get the name of the function right. It takes you straight to that function. And again, if I didn't know the name of the function, I didn't have a concept for it, I just knew part of the name, I could use this command apropos and then the part of the name I know in quotes. And it will give me function names that have this piece of text in their names, not in their descriptions, like with 2 question marks. Some functions don't have any mandatory arguments. You can just type in the function and empty parentheses, and it will return something. So this function, for instance, returns the current time set in your computer. Most functions that will do analysis, they require at least 1 argument. So here, you can't provide mean empty, you have to at least give the data for which you want the mean. So I'm going to say I want the mean for the column weight in the data set chick weights, and it gives you the mean. But let's look question mark mean to see what the help tells us about the arguments. So it says the first argument is data set, there is an argument called trim, and there is an argument remove NAs, remove missing values, and those have defaults. So if I don't provide them, the function is just going to use the default, which is what it's doing here. But now I'm going to insert a missing value at any position in that variable. So there is a missing value now in chick weights weight, right here. If I try to take the mean now, it doesn't give me the mean. So the default is do not remove NAs, and it cannot calculate the mean if there is a missing value there. So I change this argument to remove NAs equal to true. It will now remove any missing values before calculating the average, and will give me an average. This is really important because usually we write scripts, so we would write all the analysis we want to do. And if we don't think about things like this, that the data coming in could have missing values, we'll have an error on the beginning of the script and not realize for the rest of the script. I've said this before, if you provide arguments in the order they're expected, then you don't have to name them. But if you name them, you can provide them in any order. So here I am providing remove an ace first, but I named it, so it's okay, it will run. Here they are not named, but they are in order, so it will also run. This one, the function is going to understand that I'm giving true to the argument trim, which is the one that comes after data. Since it's not named, it will take from the order and it will give me an error message because trim expects a numeric argument. I'll just load the data again to override that I input a missing value before. Now let's look how you apply functions to more than one dimension, because here I've always been calling one column on the data frame check weights. So even though I'm pulling it from the data frame, what I'm actually providing to the function is always one vector. When you want to apply functions to the whole data frame or matrix, you could use functions that will go column by column. For instance, call sums will take the sum for each column, the whole column. Call means will calculate the mean for each of the columns and return all the means. Those are specific functions, you would have to know their name. The best thing to do is to know how to use apply. You're going to get the help for it. So apply lets you apply to an array any function you want to a margin you choose. So margin 1 is rows, margin 2 is columns, and if you had arrays, you could choose third dimension, fourth dimension, and so on. So I'm going to apply, my matrix is going to be trees, my margin is going to be the columns, I'm going to apply the mean, and we'll do the same thing that call means did. It will take the mean from each column. Notice that a lot of time the functions have this ... which is more arguments. What this means is that this function lets you give extra arguments to other things it may need from these previous arguments. So for instance, since I gave mean as my function here, I should be able to give all the arguments that mean takes, which we saw before were a trim and whether to remove an ace. So since I'm using mean inside this function, I can also provide the arguments that will be passed to the function mean. Let's see how that works. So I'm just going to assign a missing value to my data frame. It's actually a matrix. So now on the first position it has a missing value. If I simply apply a mean to every column of that matrix, for the first column where the missing value was, the mean is not going to work. But I can say apply to the dataset trees, to the margin 2, which is columns, the function mean, and then I pass on extra arguments which are passed to the function mean. And now it works. There are other ways to apply functions to rows or columns. One other function that is worth knowing is aggregate, which lets you split the data set and calculate summary statistics according to those subsets. What does that mean? So for instance, I'm again going to look at this data set. So I have the weight of different chickens by the feed they were giving. So what I tell the aggregate function is that I want to apply the function mean, and pay attention that here you have to give the function name in quotes. It's just how the function calls for it. And I want the mean of chicken weight by the variable chicken feed. If I apply this, it gives me the mean chicken weight for the groups in each feed category. A lot of functions that are applied to data frames can also be written in this format where you just give the column names. So give me mean of the weight by type of feed, and then you provide as an extra argument the name of the data set. So data equal to chick weights. It's going to give the same result, but it's a more clean way to do it because you don't have to keep repeating the name of the data frame. You just give it at the end. Aggregate can also take another notation. Instead of using the by as this tilde sign, you can also say aggregate this vector by this vector. The only thing you have to notice is that this is the notation that you could use if those vectors were not together in the same data set. So it expects the whole name of the vector, data set, $, and the column name, and you have to provide by as a list. It takes a little bit more notation to put list, parentheses, and then the name of the variable to group, but you could provide as many as you want. So you could put comma and then provide other variables, other factors to group it by. This notation here is the same notation that you use to do regression in R. So when you try to do a linear regression, for instance, and I'm going to call the help function, just for us to see that the standard, if you don't provide any argument regarding the family, it's going to assume it's a linear regression, a Gaussian family. So this is the command to do a linear regression, glm weight by feed. And if I had other variables, for instance, if it was feed and type of housing, and I had a variable called housing, you'd say feed plus housing plus age and how many ever other variables you had, and then the name of the data set where I'm going to find those variables. This is the result, but again, I just applied the function and didn't store it, didn't assign it to any variable. It prints here, but it's just for me to see, and it's not very complete even because you don't have the p-values. The best way to do it is apply the same command and assign it to a variable. And I put this here to remind ourselves that R has many more types of classes than just the ones we looked, like factors, numerical, integer. So model 1 is a class GLM or LM. If we ask to see what's the structure of this object, it's not so easy to understand. There is a lot going on there. But in time, you're going to get used with the most useful ones, which are, for instance, residuals or coefficients. Because when you run a linear regression, it's not just to see it on the screen that you want to use the results for something. So the best way to look at the results of a model is to do summary, which is actually going to give you a more organized way to look at the model. So you now have the coefficients for each of the categories and are understood those to be categories because the column feed was factors. It gives you the p-values here on this column, and here it codes them by how significant they were. It gives you a few other results here, so summary and the name of the variable of the object to which you assign your results, and then you can extract specific information such as model $1, residuals, to see the residuals for each individual observation, model 1 $ coefficients, to see the coefficients for the intercept and each of the variables in the model. And I was just mentioning there are a lot more classes in R that you end up getting used to them only when you need them for a specific analysis. So for instance, if you're working with time series, you may want to know about this class time series. And I have also mentioned before in another video that the good thing about the classes is that R is prepared to execute behaviors differently for different classes. So let's, for instance, create a sequence from 1 to 30 and assign it to the variable x. If I ask R to plot it, this is the default behavior for plotting any variable, is to plot x, y, and put it as little dots. Now I'm going to say that this 1 to 30 is not just any sequence, it's a time series. And to set a time series, we had it here on the help, it says you have to provide a start, an end, and a frequency. So if my time series was yearly, the frequency would be 365. If it was weekly observations, my frequency would be 52 because there are 52 weeks in a year. So how many data points do you have before you start a new cycle in your data? I'm just going to pretend that those 30 observations are part of a month in a year. So I'm going to say I'm starting at 1, the total frequency would be 365. If I ask to see x now, it doesn't print just the sequence, it prints the information that this is a time series, it's starting on 1, ending on 30 because I had 30 observations. This is just the default behavior to show an object of the type time series. And when I plot, now instead of the little circles, I have a line because that's the default plotting behavior for time series objects. Here the x-axis says time, and I have x counted as units of my frequency. When I was looking at the help of the time series object here, you may have noticed on the very top here, it belongs to a package called stats. So the way R works is there are lots and lots of functions, and different people can contribute adding more functions, and they do so by contributing with packages. If R would come loaded with every package that exists, it would be impossible to work with it. So you load the packages that you need. And many times you have to Google and find out what are the packages you need. It just so happens that the package stats comes loaded with R normally. As soon as you load R, this package is already there. RStudio makes using and understanding packages really easily. Here are the packages. Here are the name of all the packages ever installed, so the ones that come by default with R and the ones that I installed myself. And it has a check mark for which ones are loaded, so which ones are in use. That's why when I put $TS, even though this function TS is on the package starts, the help showed R could find that function because that package starts is loaded. There is a command to unload packages, but in RStudio, all you have to do to load or unload is click or unclick. So now it removed that package. And if I try now to ask for the function TS, it doesn't find it. The function is no longer there because the package is no longer loaded. I can do that again. If I want to do a function and I search on the internet or in help forums or I hear from someone that there is a package that does what I need, but I never use that package, I'll probably have to install it. So for instance, I'm going to install the package math. So this is the command to install packages with the name of the package in quotes, and once you run, it's going to load the package, and the package is going to show here on your list. But just the fact that it's installed doesn't mean that it's loaded and ready for use. You see, it's not checked. The command to then load is library. So when I run library mass, now mass is checked. And in RStudio, that is the same result as if I had come here and clicked on it manually myself. When you run library in the name of a package, and now the name of the package doesn't need to be in quotes anymore, it will always load the package. If you instead write require mass, then it will check if it's already loaded and only load it if it wasn't loaded before. It's a few seconds to save there. If you want, we have been getting help for specific functions. If you want help for a whole package, you type it like this, help package equal to mass, for instance, and then the help lists all the functions that are available in that package. So all those functions weren't available before, and they are available now because I loaded this package. And if you want help to a specific function, you can just click here, and then it will take you to the help for that function. I just wanted to show one last case where I need a function and it's not available in R because I need to go find a specific package. So here I'm going to create random numbers from a normal distribution, 500 random numbers from a normal distribution with mean 0 and standard deviation 2. And I want to apply a cumulative sum to this time series. If I try, it says can't find it. If I use 2 question marks, now I'm going to look anywhere for this word, and then it gives me different packages. So you see there is a CK sum in a package called bytops. There is an algo cumulative sum in a package called surveillance, and so on. So I read here and I finally decide that I want this cumulative sum chart from the package QCC. So I install the package first, and you only have to install it the very first time you use it. If you already have it installed, you can comment this out with the pound sign because you're not going to need it again. Again, I just installed, I didn't load, the function is still not available. I load the package, and that you need to do every time you're going to use it in a new R session. So once I load, as long as I don't close RStudio, I don't close R, that function is going to be available there. So now I do have the function cumulative sum, and here are the arguments it takes. And I am just going to run a cumulative sum on this without giving any other arguments, letting it borrow from the default values. The default is to apply and to plot, so it plots the result here. I can zoom to see this plot a little better. This was it for functions, except that if you download the notes for this video, I have recommended a few functions that you can try to apply on your own. As usual, these functions are all in the page for the VetSim project at sva.sa. And if you have any questions, do not hesitate to send me an email.